for joining our event. My name is Eleni and I work as a quality engineer in Albelli, and also I'm one of the organizers of these meetup events. Today it is our fourth event. Previously we used to host our events at the Silver Tower at the center of Amsterdam, where our company is located. But because of the corona, we decided to switch to webinar. So this is our first online event. Today's topic is Kotlin, and it's going to be presented by Cristian Postoaca, a .NET developer from Albelli and a big Kotlin enthusiast. We're going to start with a short introduction to Kotlin, and we're going to continue with two demos. First, we're going to have a demo about how to write an API test using Kotlin, and we're going to continue with a UI test using Kotlin. If in the meantime you have any questions, please post them at the Q&A section, and we're going to answer to all of them at the end. Thank you, enjoy it, and welcome, Cristian.
Thank you, Eleni. So as Eleni said, my name is Cristian. I've been working for Albelli for about 3 years. I'm part of the Kiosk Monkeys team that handles the ordering system, the payment system, the checkout part of our website, and a bunch of other APIs. Basically, we are one of the backend teams. And today I want to give you a brief introduction to Kotlin. And afterwards, we are going to take a look on two demos. One of them is an API test, and the other one is a UI test, both of them using Kotlin. So let's start. So what if there were a language not bound by any outdated concepts? So in Kotlin, you can write procedural, functional, and object-oriented code as part of a file, project, or even code base. It has a write less, do more approach, similar to Python, where the syntax helps you to write compact and very expressive code. It's also designed for productivity because it learned from the mistakes of the older languages such as C++ or Java. And here we have an example of the hello world. As you can see, if you want to just print hello world on the screen, you can just use this notation. You just declare the function, the entry point, which is main, and then you use this helper function to print hello world. To give you a comparison with Java, you would have to declare the package, the class, and the static method, which doesn't really help you express what you want. It's just boilerplate. And Kotlin can be used on a lot of platforms. So it was mainly designed to be used in the JVM, but you can also use it for Android, where it's in fact the main development language there. It can be used in JavaScript, both in Node.js and in the browser. It also has a native implementation in the works, which works with low-level virtual machine, and it allows you to compile native applications. Nowadays, it's also used for data science as an alternative to Python. It has full support for coroutines, which are basically constructs that allow you to write asynchronous or parallel code in a very clear way. And also it supports multi-platform libraries. So you write the code for a library once and you can use it on all the platforms that you see here. And despite being a young language, it actually has a pretty big ecosystem. This is a script from the awesome Kotlin repo, and here you can see some frameworks that are developed right now. So you can use it for web framework, like for server-side frameworks for testing, for game development, and even for GUI development. Kotlin is also interoperable with the languages on the platform that's running on. So if you run it on JVM, it has full interoperability with Java and also with Scala. If you run it in JavaScript, you can easily call JavaScript code from it. And what is actually Kotlin? So Kotlin is a cross-platform general purpose language that makes heavy use of type inference and also functional programming ideas. It was designed by JetBrains because they wanted a language with the feature of Scala, but with a much faster compilation time. So they created Kotlin as a hybrid between Java and Scala, and they are currently using it for basically all their code base. They develop IDEs, tools, and nowadays even web frameworks. So why would you choose Kotlin over other languages? First of all, because Kotlin is very expressive. You can write Python-like code but still enjoy the features of a statically typed language with a very powerful framework and running on the JVM platform, which is very, very fast. It has the full backing of JetBrains and Google, where it's heavily used. And Kotlin code can be written as a script, or you can write a full-scale project in it or an entire code base. But because today we are going, this webinar is about testing, we are going to focus on Kotlin for testing. So the basics. Kotlin works with all the existing Java IDEs. The tooling of Java also works with Kotlin, and it's actually what you should use if you have a Kotlin project. Here we have a snippet of a Gradle script where we just add Kotlin. So we reference it in this plugins area. That's it. Then you can just use Kotlin in your project. The rest is stuff that you would similarly reference for Java. Kotlin can be used fully with your favorite Java libraries. To give you an example, here we are going to use the Selenium WebDriver. So what we do, we just add a dependency the same way as we would do for Java. We add the Selenium Chrome driver, and then we can just import it and use it in our code. Using Java libraries is really cool, but they don't actually leverage the full power of Kotlin. I'm also going to show you how to use a library that makes use of the idiomatic Kotlin constructs. So we are going to reference CodeTest, which is one of the most popular testing frameworks for the Kotlin ecosystem. Once again, we have to implement it inside our Gradle script, and then we can use it in our code. This is an example of a Kotlin script where we just we are given a random Albelli account, and we go through our Albelli website, and we try to click to toggle the more products made menu. So we start by defining a test account, and then we call Selenium to open the website. We do some logic there, and that's it. As you can see here, this code is quite different from Java. So first of all, you have this braces syntax, which is quite foreign. You can also declare anonymous objects as opposed to Java, where you always have to define classes. And also, you have these 5.seconds, which is quite foreign compared to Java because you cannot really call methods upon a number. So I'm going to explain you a bit what happens here. First of all, this given syntax is actually just a function. So how it works, basically, Kotlin offers you a way to define anonymous functions if they are the last argument inside a function or a method with this special braces syntax. So here I have an example of a very, very simple function which tells you if a predicate is true. In the first example, you can see the classic style to call it. It's very similar to the modern versions of Java. You just pass the anonymous function as an argument. The second one is the more idiomatic Kotlin way, which allows you to call it with the braces. Why this matters is because you can create strongly typed DSLs in Kotlin, which is a very simple and expressive way to structure your code. So if we go back to this given call, you just realize that actually given is a function with two arguments, a string and then an anonymous function. And if we go back to the code, here we can make use of this syntax to actually define the DSLs. So we know that we are given a random Albelli account, and then we perform some steps, and then we continuously try to close any Albelli pop-ups, for example. So you don't have a lot of boilerplate, and you know almost exactly what's happening without knowing too much about Kotlin. You also have this 5.seconds syntax. What this is actually an extension property. So Kotlin allows you to extend existing types without actually extending them with another class. What you do, you just write a function with a special syntax, and this allows you basically to call that function upon the type itself. This works in a similar way with the static methods in Java, but this syntactic sugar really allows you to simplify your code a lot. So let's move further. What about everything else? So what about the other features in Kotlin? Well, how would you use it in a typical setting where you just want to do something with it, right? And what I did here, I took some code from our legacy testing solution written in old Java. What it does, it verifies if a smaller copy is added correctly. A smaller copy is part of our product offering. So whenever we try to buy a photo book, we also offer customers the possibility to order a smaller copy. Here you can see that we get some variables from the cart, the shopping cart, the string, the integer, and so on. We do some API calls based on those variables, and then we do some assertions. Take a look at this code because we are going to see the Kotlin version of it. So this is the Kotlin version. IntelliJ IDEA has a feature that allows you to just convert any existing Java code to Kotlin. And here you can see some differences. First of all, the function declaration is quite different, but in the end, you can infer that it works the same way as in Java. A more interesting thing is how you declare variables. In Kotlin, there are two types of variables, mutable and immutable. And long story short, what it means is that immutable variables cannot be reassigned afterwards. This prevents a huge amount of bugs, and it also conveys the meaning behind your code in a much clearer way. So val is actually the syntax used to declare immutable variables, and var is to declare mutable variables. So here we try to get a shopping cart variable from the test context. We don't have to declare the type explicitly again because Kotlin makes use of type inference. That is, it knows which type your variable has based on what this getVariable function returns. This gives the code much more compact and it's a bit more easier to read. Then we do this remove if using the special DSL notation. So we remove all the cart items that have an ID with the original photo product ID equal to it. And then we do some assertions. One cooler thing that you see here is that Kotlin also has string interpolation. So what IntelliJ IDEA decided to do is that instead of having a different branch for this if and more code, it just added it as string interpolation inside the string. So what you see, this glossy is going to be added to the string itself if this condition is true. And this is it. Now I'm going to show you the interesting parts, which are the demos. So the first one is a Kotlin API test. It's an IntelliJ IDEA project using Gradle as the build script. We are adding support for Kotlin here, for the Kotlin coroutines, which are required for Webflux, which is the HTTP client that we're going to use here. And we reference Cucumber Java 8 and JUnit. Since this is a Cucumber application, this is the entry point of it. So we declare this class test runner. And as you can see here, we don't really need any body. And Kotlin doesn't force us to do so. You can just declare a class like this. And we have these Cucumber options, features, tags to point to the right folder. This is a Java library. It knows nothing about Kotlin, but it fully works with Kotlin itself. Then we are going to look over the feature file. The test itself is very simple. So we are just going to create a card with a voucher inside, and we are going to see if it was created correctly with all the properties intact. The definition is defined here. So we are going to use something that Cucumber calls Lambda Notation. We are going to have to use these helper methods, given, when, then, where the first argument is actually a string that matches the one in the feature file, and the second argument is a Lambda function. So what we do, we just create a card, we add the voucher to the card, we check if the card was created correctly and if the properties are defined correctly. So let's just try to run. And this is it. The test passed. Everything was okay. It's very fast because it's just a few API calls. Now I'm going to dwell a bit deeper into the code. One of the great things about Kotlin is the ability to have data classes. You might know about them as records from other programming languages. So what you do, you define a data class with a name and with a bunch of arguments on the constructor. So here, for example, we have this cart ID, which is immutable and it's of the type nullable integer. Uh, Basically, what Kotlin does based to it is to generate a full class with all these properties, with the getters and setters, and to overwrite all the helper methods that you use to use the object as a POJO. So you're gonna have to string, get hash code, copy, and equals all defined for you without writing any code. And because all these variables are immutable, you can only instantiate this object and you cannot change them afterwards. And now I'm going to make use of a very neat IntelliJ IDEA feature that allows you to decompile the Kotlin bytecode into Java code. So this is more or less what would be the equivalent Java code. So as you can see, Kotlin generates all these things to you, getters, setters, it generates the constructor, and it also generates the hash code to string and so on. If you ever work with collections and other APIs, you're gonna, or if you ever define POJOs in Java, like simple objects, you know how painful it is to actually write one because you have to make use of your IDE to do it. And the file itself can become really, really big. Well, for Kotlin, you just have to use this very simplified syntax and everything is mostly done for you. And then I'm going to show you the cart API client that we have, cart API being the API that we use for this test. So we are using web client, which comes from Spring, and we use this builder API to do a post to this URI using application JSON. We just provide the body as the request, and then we do this. This happens because this web client is actually designed as a synchronous first. It has support for Kotlin's coroutines, but also for reactive programming, which is a very advanced concept. But in our case, we don't need all of that, so we can just run it as blocking. And we do the same for the other HTTP calls. And now let's see how you would instantiate an object. So for example, let's pick this generates €15 voucher. As you can see, this function doesn't have to reside in a class because Kotlin itself offers you the ability to write top-level functions. Here, we instantiate the shopping cart item itself. You don't need the new keyword. And also on top of that, you don't need to reference the same variable and then access its methods or fields. Here you can do all the initialization inside the constructor in a very readable way. As you can see, this is a very complex object because it's used in one of our most legacy APIs, and you can still read more or less what properties are assigned to. And now I'm going to decompile this into what it would look like in Java. So this code gets pretty complex because basically what it does here, it builds some properties in advance and then assigns them to a constructor. And then those other properties are assigned themselves to a new constructor. Once again, this would take a lot of Java code, especially if you want to use it immutability. But Kotlin does it for you and does it in a very nice and clear way. And then we are going to go back to the most interesting part, which is the cart creation definition. So here, what we do, we define a created cart, we create a cart, and then we assert if it's not null. One interesting thing again is that you can import the static methods of an object in Kotlin. So basically, you don't have to write assert dot something all the time. You can just import everything, and then you can just use the methods themselves. We are going to use the properties of this class as a cart ID and a voucher. These are going to be the text context, basically. And yeah, then we add a voucher. We just check if it's blocking or not. sorry, we just get the cart in a blocking manner, and then we get the single cart item that we have in that cart. You are going to see some other weird things here. What is this and this? Well, this question mark basically allows you to evaluate a field or a property inside an object. And if this part is null, then this entire expression is gonna be null. Otherwise, it's gonna go on to here. And the same way, then, well, it doesn't matter. It's gonna either be null or this property. This works like this because Kotlin has nullable types. That is, usually in Kotlin, when you define a type, you cannot assign null to it. In order for you to be able to do that, you need to have this special syntax with a question mark. And then this is going to be a nullable type that can actually take null. This double question mark tells Kotlin that this part of the expression here is never going to be null. And if it's ever going to be null, you're going to get a null pointer exception. This nullability feature is actually very, very important because null pointer exceptions have been one of the biggest problems in software development. Also, people tend to use null to express the absence of a value, but that's not always the greatest idea. In Kotlin, you can actually use other ways to express this. And when you define your contracts, you can clearly see that the contract can never be assigned null because it is so in the definition. So yeah, the rest is quite self-explanatory. Then we just do some assertions on the objects themselves. Once again, we make use of this notation because otherwise we would have to write a lot of ifs. So if this is not null, if this is not null, and so on, and this would create a lot of code. Well, here this can only return null or this property here. So this code here is always going to work. And once again, if I'm going to decompile it to Java, you are going to see exactly what I'm talking about. So here, basically, for each part of the expression, it does a null check. And yeah, Kotlin does all of this for you. The second demo I have to show you today is a bit more complex. It's actually a UI demo. So this is once again an IntelliJ project. Instead of using Cucumber and the web, the HTTP client, we are actually using CodeTest, which comes from Kotlin and Selenium. CodeTest is written for Kotlin and Selenium for Java. So what this one does, actually, it goes to our Albelli website, it tries to order a voucher, and it goes through the flow until the payments page where we cannot proceed, obviously, because it's on production and we would have to pay real money. So this is a way to write a test in CodeTest. CodeTest offers you the choice to write code and specifications in different ways, like BDD style, JavaScript style, and so on. But now I chose to use the BDD one. So given a random Albelli account, we open the Albelli website. We try to close any pop-ups because we have a lot of marketing offerings on our Albelli website and they might interfere with the Selenium actions. We toggle the more products main menu. We choose the voucher. We reach the vouchers page where we actually add the voucher to the basket. Once again, we close pop-ups and then we go through the checkout. And now I'm just going to start it to show you how it works. So now we've reached the well, as you can see, sometimes UI tests are very complicated and they break. We can see why this happened Here, I assume it's because we had a pop-up or something else. So I'm going to explain to you why this happens later. I'm just going to try to run it one more time. And this is a bit of a problem sometimes because, of course, this is our production website and we are not always really well aware of what code is injected there. Like if we have any pop-ups or anything, it could break the flow. So this time it worked fine and we reached the details page, and then now it should go to the payments page, which happened. UI tests, of course, are always a lot more complicated. So the code itself reflects that. We can go here to the code, and this part, for example, is quite simple. We just open the Albelli NL website. The next one is a bit more complicated because here we are trying to close any Albelli NL pop-ups for 5 seconds. And we are just going to call this code hoping that that is going to happen at some point. Because the nature of operating on websites and triggering events on them is asynchronous and non-deterministic, you cannot always do it properly. So how this code works is that it's going to run the code inside it every, let's say, 25 milliseconds for 5 seconds. And eventually that will work or not. And the same way here is going to try to find this element and to move the mouse over it. This element being the more products made menu for 5 seconds. And it's going to do so until this code stops throwing exceptions. Once again, because there are several elements interacting in the website itself, and it's not an instant operation. We move on doing the same with and eventually. We are trying to choose the voucher from the dropdown. We click the button. We try to close any existing pop-ups again. We continue with the order. We key in our email and password and so on. So this continually and eventually is provided by the code test framework. It allows you to run non-deterministic code in 2 ways. Either it will try to run it for an amount of time and it will succeed or not, or it will keep trying to run it every X milliseconds for a duration of the time. And here we do so in a very nice way, because usually when we do this in Java, we are either trying to suspend the thread or we are going to write a loop ourselves. Basically, we have to take care of this one way or another. But here, just calling this method with some code inside already does all the job for you. The interesting thing here is that and continually doesn't actually come from the framework itself, because the framework only defines and plus continually. So what we do, here we define an extension method that basically composes this and continually and then runs the code inside. And this is an example of actually using extension methods to make the code more readable. So we didn't have to extend this given scope that's provided by the library. We just wrote this code in a separate file, and then we can just use it as if it's part of the library. Here, once again, we define some extension methods for the most common Selenium operations so that we don't have to write this huge code all the time. We can just do it once here and then we can use it in other places. And in the end, basically, you can just compose all these methods themselves and just have them quite readable, because here you can infer from the name and continually, it will just try to run this code continually for 5 seconds and so on. And in my opinion, this is where all the magic of Kotlin comes from. You can write very expressive code and you can do a lot of things with that code with very little lines. And yeah, well, that's it. I hope you enjoyed it. And I'll give it back to you, Eleni.
Okay, thank you, Christian, for this presentation. I see we have a question from Bo about the slide 14 and what is a builder, if you can go back to this slide.
Let me see. Yeah, the builder is actually part of the Selenium API, is the actions API they provide to simulate user actions on the web page. So if we go back to the code, we are going to see its definition here. This comes from Selenium API itself. So it's just to emulate user actions.
Okay. Is that clear, Bo? I think yes. Okay, if we don't have any further question, I think it's time to wrap this webinar. Thank you all for attending our event today. I would like to let you know that we are planning to host another meetup event in mid-November, and the topic is gonna be UI testing with Cypress. We are gonna keep you posted through the meetup platform about more details. And once again, thank you. And we have a small present for all of you attending our event today. You can go to our website, albelli.nl, and you can order any photo products you would like a photo calendar, photo book. And by using the discount code Albelli Meetup, you're gonna receive 35% discount to your order. So thank you again for joining. See you all in November. Until that time, stay safe.
Thank you, guys. Bye-bye.